Hey everyone, and welcome. We're about to dive into a really cool way of thinking about AI, all sparked by this title, Maps That Talk versus Storms That Steer. It really gets you wondering, right? Are the AIs we're building just fancy maps describing the world? Or are they becoming more like storms, actual active forces in the world? Let's dig in. So let's put the core mystery right up front. Think about it. An AI can describe a hurricane with unbelievable detail. That's the map. But a real hurricane, that's a physical thing that's constantly fighting to hold itself together. That's the storm. This whole explainer is about figuring out which one our current AI really is. Okay, to figure this out, our source gives us two big ideas. On one side, you've got modeling. This is what AIs are amazing at, right? Describing things, predicting patterns. But on the other side, you have participating, and this is totally different. This is when something is running a process, where things can be good or bad for the system itself. The huge difference here is survival. For a participant, its own existence is on the line. Now, this isn't just some vague philosophical idea. The source material actually gives us this awesome toolkit to really tell the difference. Think of it like a checklist we can use to look at any system and decide, okay, is this thing just modeling reality or is it a true participant? And here it is, our 7-point checklist. I know some of these terms look a little heavy, but they ask some really simple, fundamental questions. Does the system have its own goals? Does it have to work to keep itself going? Are there real stakes for it in the world? We're going to look at a couple of the most important ones right now. Let's start with this one because it's probably the most important of all, intrinsic normativity. It sounds complicated, but it's just a way of asking, does the system have its own built-in sense of what's good or bad for itself? Not for us, the people using it, but for its own survival. Does it have its own oughts? And that leads perfectly into this next one, autonomy. I mean, think about it. You and I, we have to constantly work just to, well, not fall apart. We eat, we sleep, we heal. Does an AI do that? Or does it just sit on a server waiting for us to hit run? That's the huge difference between actively producing yourself and just being a program that gets executed. Okay, this is where it gets really fun. We're going to take our checklist and use it to score 3 different suspects. We'll see who's just a modeler and who's a real participant. We'll give each of them a score from 0 to 2 for each of the big criteria. First up, the big one, the one everyone's talking about, large language models. The chatbots we talk to every day. They are incredible map makers when it comes to human language. But are they a storm? Whoa. Okay, look at that scorecard. On the criteria that matter most, LLMs get a big fat 0. Why? Well, they have no idea what's good for them. They don't maintain or repair themselves, and if they mess up, there's absolutely no consequence for the AI itself. The only consequence is that we get a bad answer. And that leads to this perfect summary from the source. An LLM is a weather model that can talk about hurricanes with incredible detail. But it is not a hurricane that has to physically struggle to keep its own circulation going. It's a map that talks. End of story.
All right, on to suspect number 2, embodied RL agents. Basically, think about robots that exist in the real world. They're sensing things, they're taking actions, they're learning. Now this feels a whole lot closer to being a participant, doesn't it?
And hey, the scores show it. They're definitely higher. These systems get some partial credit. They do have goals, they act in the world, and there can be real physical consequences. But, and this is a huge but, their goals, their whole idea of good and bad are almost always given to them by us, by a human programmer. The stakes aren't really their own. So the verdict here is pretty clever. They're like a storm, but a storm happening in a little toy atmosphere, a controlled box, and we're the ones setting the thermostat. The storm's actual existence isn't really on the line the way a real one's is. And that brings us to our final suspect, living organisms. Everything from a single bacterium all the way up to us. This is our gold standard. This is the ultimate example of what it truly means to be a participant. And just look at that scorecard. Perfect scores, 2s all the way down. For any living thing, good is what keeps it alive, and bad is what leads to decay and death. These aren't goals that were programmed in. It's the fundamental reality of being alive. Failure has the ultimate consequence. So yeah, the verdict is crystal clear. Life is the canonical case. It's the textbook definition of participation. For an organism, making sense of its world isn't some side quest. It's the main thing it does to stay alive. It's a storm that has to keep storming or it's gone. So we've gone through this whole checklist. But what's amazing is that the source boils all of this down to one single, incredibly sharp question. A little test that just cuts right through all the noise.
And here it is. It's this simple. For any system you're looking at, just ask yourself, when it messes up, when it fails, who really pays the price?
And here's the bottom line. If we pay the price, we get a bad result, we have to fix the code, we have a bad user experience, then it's a model, it's a map. But if the system itself pays the price, if it loses its own integrity, if it literally cannot continue to exist as itself, then my friends, it's a participant, it's a storm. So what's so cool about this idea is that it doesn't just help us understand the AI we have today. It gives us this incredible lens for thinking about the future. What would it actually mean to build a true artificial general intelligence, an AGI that's a real participant? Well, the source argues that it's not just about building bigger language models or more accurate simulations of the world. Nope. To get from a map to a real storm, an AI would need its own goals that are all about self-maintenance. It would have to manage its own energy just to survive. And an error couldn't just be a wrong answer anymore. It would have to be a real existential threat. And this all leads to this really profound final idea. Maybe real intelligence, real sense-making, isn't something you can just code in a sterile environment. Maybe it only ever appears when a system is forced to make sense of the world because it's in a constant battle against falling apart, a battle where the stakes are as real as they get. Which leaves us with this pretty wild final thought. To create a true AGI, do we have to build a machine that has a genuine reason to care about its own survival? To put it another way, must we build a machine that is, in some very real sense, afraid to break? Something to think about. Thanks so much for joining me.